Hey all, this is a medium difficulty question. It's a SAT math practice question from linear algebra, a linear functions question. Objective is to find out which of the following is the equation of the function. We have some information about the function provided here, right? Solving this question entails 3 steps. At the end of solving this question, we also have a bonus question that you would solve and post the answer to the comment section of this video. But before that, have you subscribed to the channel? If so, thank you so much. If you have not subscribed, please subscribe and like this video if you find it useful so that it gets recommended to more people and more SAT aspirants can get value out of such videos, right? Let's get started. We know that this is a linear function f satisfies f of minus 1 equals 5 and f of 3 equals minus 3. Which of the following is the equation of this function? It's a linear function, that's what we have. The form of a linear function in slope and intercept form will be y is equal to mx plus c. Y and x are the variables, m is the slope and c is the y-intercept. What does it graphically represent? A linear function when plotted on a graph will essentially be a straight line. Say this is your x-axis, our y-axis is nothing but f of x. Any point on this line is essentially going to be an x comma y, which is x comma f of x. So this is what is the form of a linear equation in slope-intercept form and what it represents graphically. Now the next step is to finding out one of these two. Let's start with the slope, which is the ideal one to go with. How do you compute slope? If you have 2 points on a straight line, you'll be able to find out what the slope of the straight line is. So the next step for us is to determine the slope. To find the slope, the prerequisite is to have the coordinates of 2 points. Do we have that? Yes, we do. X comma f of x, right? When x is equal to a minus 1, we know f of x is equal to a 5. So minus 1 comma 5 is a point on this line. When x is equal to 3, we know f of x is equal to minus 3. So 3 comma minus 3 is another point on this line. So we have point number 1, point number 2 available to us. So next step is finding out the slope of the line. If you know 2 points on the line, coordinates of 2 points, x1, y1 and x2, y2. The slope of the line is y2 minus y1 upon x2 minus x1. Let's find out what we have here. Let's take this to be a y2 minus 3, y1 minus 5 divided by x2 minus x1, which is 3 minus of minus 1, which is equal to a minus 8 divided by 3 minus of minus 1 is the 3 plus 1, which is equal to 4. So the slope of this line is equal to minus 2. We said the slope-intercept form of a line is y is equal to mx plus c. M is found out to be equal to a minus 2. So the equation of the line is minus 2x plus c. The next step is finding out the y-intercept. What is that? Substitute this value. We know y is equal to minus 2x plus c. When x is equal to a minus 1, we know y is equal to a 5, which is f of x. Plug that in. 5 is equal to minus 2 times minus 1 plus c. So 5 is equal to, this becomes a 2 plus c, or c is equal to a 3. Now that we know the intercept and the slope, the equation of the line is y is equal to minus 2x plus 3. Check out the answer options. Answer option A is the correct answer. Minus 2x plus 3 is the correct answer to this question. So solving this question entails 3 steps. First, identifying 2 points on the line. Essentially, we got it from x comma f of x, the 2 values that we had. Then finding out the slope, y2 minus y1 upon x2 minus x1. Once we found the slope, then substitute the value of x and f of x in that with the slope also included into it to find the value of the intercept. Once we have the intercept, the equation is done. Y is equal to minus 2x plus 3. Here is a bonus question that you can solve. Very similar, right? A linear function g satisfies g of 2 equals 1, g of 5 is equal to 10. Which of the following is the equation of the function? Solve this question and post your answers to the comment section of this video. Best wishes for your SAT preparation.